My name is Christopher Chen, and this is my Lab 6 for Physics 2212. The goals were to collect data about a magnet falling through a copper pipe and then to model this phenomenon in GlowScript. One of the laws we used was Faraday's law, which states that the E field dotted with the path length is equal to the negative of the derivative of magnetic flux with respect to time. Some more laws we used were the magnetic force law, which states that the force on a wire is equal to the current running through the wire times its length crossed with the B field, the external B field, and also we use Ohm's law. The system is a falling magnet and the surroundings are the pipe and the earth. Here are the procedures for the lab. And here are all the results that were collected from each stage of the lab. Here is all the code for the computational model, and in the center bottom picture, we see the results from that model. The computational model predicted a time of 4.435 seconds, which is pretty close to the 0.4 that was measured. Some sources of error are that the timings were pretty inaccurate, and that there are also friction and air resistance. If resistivity was as close as possible to zero, then because it is proportional to resistance, there would be almost zero resistance. This would cause a huge induced current because of Ohm's law. This would create a huge magnetic force, and so the magnet would take a really long time to fall through the pipe. Holes in the pipe would then disrupt the rings inside the pipe, and this would cause induced current to not be able to flow as well, and so there would be less force generated and the magnet falls much faster.